became a legend before it even rolled off the production line. Shrouded by a mantle of stealth, it can fly into harm's way, deliver 40,000 pounds of destruction, and remain almost undetectable. Now, the B-2 stealth bomber on Modern Marvels. Cold spring morning on March 24th, 1999, in the skies over Yugoslavia, two B-2 stealth bombers are about to penetrate enemy airspace for the first time.
Early on, we weren't sure. What the enemy was capable of seeing or anything like that. In fact, the first night of Operation Allied Force, as the airplanes are flying into Serbia, there was a MiG engagement with an F-15 directly below the airplane. And it turns out the MiG had no idea that the B-2s were directly overhead. And hearing that report just started to really quickly build the confidence in stealth technology.
In the cockpits, the two-man crew is entering its 14th hour of continuous flying. Having refueled over the Mediterranean Sea, they move into stealth mode as the sleek shapes of the B-2s vanish into the night sky.
On the way there, you're not so much nervous as you are anticipating what you're about to go through, but you're also taking advantage of the time that you have to prepare yourself to do it well. And so you spend time studying imagery and studying the targets and familiarizing yourself with where the threats might be.
The two B-2s separate, one above the other, and climbing to combat altitude, begin their carefully choreographed bomb runs. The B-2 pilots have no chaff, no flares, no high-speed afterburner, and no missiles to fire back. They only have one thing to protect them: their stealth.
Normally on a training mission, when we're just simulating the release of weapons, we don't open the weapons bay doors. Obviously on a combat mission, when you're dropping weapons out, the doors do come open. And so there's drag on the airplane, there's noise on the airplane. There's a clunk when the weapon falls off the airplane.
High over the target area, the aircraft shudders as weapons shoot out from its twin rotary launchers in the bomb bay of each B-2.
The most unique aspect of it, which really kind of gave me the sense of, hey, this is for real, is my first release when the weapons started to come out and you felt the weapons dropping and being discharged from the airplane. That's when the hairs on the back of my neck just started to kind of raise, and I realized, hey, this is for real.
16 classified targets, 16 direct hits. At the B-2's home base in Missouri, anxious commanders scan the teletype machine for confirmation of the raid. Suddenly there is a text: Darth 01 and 2, clean and green. The B-2s are safe and heading for home. In the final year of the 20th century, the flying wing had come of age and gone into battle. But nearly 100 years earlier, men had dreamt that the flying wing was the future of flight and the future of war. But it wasn't until the early 1930s that the dream became a reality, when two young brothers, Reimer and Walter Horten, first began to design wings for the new Nazi regime in Germany.
The Horten brothers were very interested in highly efficient gliders. And it's not such a great leap of imagination to realize that the most efficient form for any flying machine is just a pure wing.
With the outbreak of World War II in 1939, the brothers continue their groundbreaking work under a shroud of secrecy. By 1941, they are exploring the use of a transport wing to help in the planned invasion of Britain. At the same time, another German, Alexander Lippisch, is working on his own wing design, when in late 1941, his Me-163 Comet crosses the 600-mile-per-hour barrier for the first time. The potential of rocket power combined with a flying wing design could change aviation history. Meanwhile, the Horton brothers are going down another path. By 1942, they are working on a 61-foot wingspan aircraft called the HO-9. This would be powered by the Junkers turbojet engines that were to be fitted to the ME-262.
The Horton number 9 was the pinnacle of the brothers' development of the flying wing. And the prototype achieved a speed of something like 500 miles an hour. They had clearly demonstrated that you could build a vehicle with jet engines, that you could fly it, that it had very high speed potential, and so they had really validated the concept.
Another of Reimer Horton's designs is the HO-229. Built of wood, and with its engines housed on the wings with their exhausts vented on the top of the wing, this aircraft would have been extremely difficult to detect. But if it could have flown, it would have had a top speed of 620 miles per hour, the fastest aircraft in World War II. But while the Germans are developing their jets, a 40-year-old American aircraft designer named Jack Northrop is quietly working on a flying wing design of his own. Jack had been dreaming about flying wings since the 1920s, and had long held the belief that the way to success in wing design was by reducing the drag created by a tail and fuselage.
Northrop's idea was, first of all, to minimize the tail and the fuselage, and then, as a last step, to get rid of the tail altogether. So he went through a whole series of smaller steps in order to achieve the all-wing configuration.
In December 1942, his NIM flying wing takes to the air, and over the next few years, more and more of his designs are being refined and tested. But by May 1945, the long and bitter struggle to defeat Nazi Germany is over. Its industrial and technological centers lie in ruin, along with its dream of a flying wing aircraft. But Jack Northrop is convinced that where the Germans failed, his wing will become the greatest aircraft in the world. All he would need is the raw power to do it. Germany's Horton brothers were the first to utilize stealth technology with the invention of the HO-9 jet in 1942. The plane's wings were coated with a wood carbon powder composite that could absorb radar waves and escape detection. You are watching the B-2 stealth bomber on Modern Marvels. May 1945. Nazi Germany is smashed into submission, and with it are its hopes and dreams of building a flying wing aircraft. But while post-war America continues to build conventional aircraft such as the B-29, one man pursues his vision. In 1946, Jack Northrop tests his massive 400-mile-per-hour XB-35 flying wing. Powered by 4 turboprop engines, this aircraft is seen by some as the bomber of the future.
This was where Northrop's vision really started to take shape, because the XB-35 had a wingspan of about 60 meters. This is a big airplane, even by today's standards. Its problem was that whilst its top speed was about 400 miles an hour, its speed in long-range cruise was only 185 miles an hour.
Just a year later, Northrop unleashes the new YB-49. Powered by 8 Allison jet engines, this 172-foot wingspan Goliath is capable of flying at over 500 miles per hour at a ceiling of 40,000 feet. Jack Northrop has taken the American wing off the design boards and into the air.
Now, a preview of the flying wing transport of tomorrow.
Jack Northrop's vision for his flying wing is not just as a bomber. He also sees it as a passenger aircraft. Because the wing could carry far greater loads than conventional aircraft, his airliner would be capable of carrying 80 passengers with an observation lounge and an ability to fly coast to coast in 4 hours. But the YB-49's days are numbered. Although years ahead of its time, it is incredibly difficult to fly. And without computers to help control it, the U.S. Air Force feels that as a bomber, it is too unstable and dangerous. In late 1949, and in an unprecedented decision, the government orders that all Northrop YB-49s are to be destroyed. The flying wing looks destined to be dumped into the circular file of history.
From the Air Force's point of view, I don't think you could quibble with the decision they made on the day, given the vehicles that were on the table in front of them.
But the destruction of the first flying wing comes at a perilous time in history. Relationships between East and West are rapidly deteriorating, and the Cold War is heating up. The world enters a new era of nuclear power and nuclear testing. The Soviet Union has built up a huge arsenal of weapons, and the West responds. In a policy that is known as MAD, mutually assured destruction, the heavy bomber is seen as the first line of attack. SAC, Strategic Air Command, puts into place a global system called Operation Chrome Dome, in which massive B-52s would constantly patrol the Earth, ready at a moment's notice to fly to any target deep within the Soviet Union and attack. But SAC is also alarmed at the Soviet Union's new improved radar and SAMs, surface-to-air missiles. SAC is determined not to let its giant B-52 bomber fleet become a sitting target for the Soviet Union.
It became apparent that any bomber aircraft that had to penetrate Soviet airspace was going to have to run a layered gauntlet of air defense missiles that could shoot down aircraft no matter how high or how low they were flying. The only way to evade Soviet air defense missiles was to fly so high that you're never going to hit a target with your bomb.
What the U.S. needed was an aircraft that can evade the Soviet defense system, fly to its target, deliver its weapons, and bring its crews safely home, all under the cloak of invisibility. But to do this meant a completely new approach on designing and constructing aircraft. Every aircraft has what is called a radar cross-section. When an electromagnetic radar beam hits an aircraft, it bounces off anything that is large or pronounced, such as engines, straight wings, or cockpits. The radar operator sees all this information coming back and can determine the size, height, and direction of an aircraft. This is known as the aircraft's radar signature. But if you can hide this information from the enemy's radar, then the plane will become almost invisible. The mantle that will shroud the aircraft from its pursuers has a new name: stealth. During the mid-1970s, the U.S. government puts out a top-secret proposal to select aircraft manufacturers. Their objective is to come up with a feasible design for an advanced technology bomber capable of long range, high payload, and low observability. By some strange irony, the winner is Northrop. 30 years after seeing the destruction of their fleet of YB-49s, Northrop is back in the flying wing business. During the early 1980s, Northrop works on designs for their stealth bomber. The entire project is buried deep within the highly classified and ultra-secret Black program. At the time, the U.S. Black program is so secret that even those that know about it are forbidden from ever acknowledging its existence. Even Congress is denied from knowing how and where money is being spent.
The Soviet Union was carefully examining things like American technical journals and the American defense budget so that they would know what threats they'd have to deal with in the upcoming years. And in order not to have this very nifty new bit of stealth technology apparent to the Soviets just by picking up the annual published defense budget, they had to make it what's called a Black program.
With costs rising higher and higher, Northrop and its partners work against the clock. Originally, the contract had been clear in its requirement. Build a heavy bomber that could never be seen by enemy radar. The solution seems impossible.
What Northrop had to do was develop a computer system that would enable the B-2, as it came to be called, to stabilize itself using feedback and the fastest computers they could get. So the stabilization of a B-2 flying wing configuration becomes a software and computer hardware problem. It becomes a cybernetic problem.
By the mid-80s, and despite some of the most stringent checks, rumors began to circulate about what might be going on behind Jack Northrop's door. Press reports, artists' impressions, magazine articles, and even automobile commercials began guessing as to what is happening behind these doors. Finally, Northrop unveils its new aircraft on November 22, 1988, when it is rolled out of its hangar before an astonished crowd. Called the B-2, the experts are staggered at this radical new aircraft. The crowds are only allowed to view it from the front, but they have never seen anything quite like it.
Nobody could possibly keep this image off a television screen. Look at this thing. It's beautiful. It's odd, it's strange, it's exciting, and by God, it's American.
But even as it rolls out of the hangar, time is running against the B-2. The Soviet Union seems like it is crumbling, and with it, the need for an intercontinental bomber. The Cold War has come to a peaceful end. It appears as though the need for a 21st century heavy stealth bomber might be consigned to the scrap heap. Before starting his own aircraft company in 1938, Jack Northrop assisted in the design of both the Douglas World Cruiser, the first plane to fly around the world, and the Lockheed Vega, the plane Amelia Earhart flew non-stop across the Atlantic. Modern Marvels will be right back. On November 22, 1988, the Northrop Corporation staggers the world when it unveils its B-2 stealth bomber. After years of working behind a complete screen of secrecy, the team of visionaries at Northrop have rewritten the rules of aircraft design. The technological array is awesome. With over 130 onboard computers controlling every element of the aircraft, the B-2 is light years ahead of anything yet built. A variety of techniques are combined to make this aircraft almost invisible to radar. Its smooth surface and shape consists of all curves, yet they are not consistently identical. The aircraft appears to continually change shape from whatever angle it is viewed, thereby confusing the radar, and whatever beams are locked onto it are either reflected into outer space or are reduced and dissipated into nothing. The B-2 is coated with special RAM, radar-absorbent materials, such as carbon fiber composites and top-secret reflective paint that further reduces its detection from the enemy. Finally, its electronic countermeasures such as jamming an enemy's radar make this aircraft almost undetectable. In fact, the B-2's radar cross-section is 1,000 times less than that of the B-52.
If you take a really big aircraft, but make it essentially really flat, then when radar looks at it, instead of seeing a big round thing flying towards them, it'll just have a sort of pancake. It's like seeing the edge of a knife.
When the B-2 makes its maiden flight on July 17, 1989, it flies every bit as good as it looks. The B-2 has a 172-foot wingspan, is 69 feet long and 17 feet high. Weighing in at nearly 154,000 pounds empty and 375,000 pounds loaded, it is a monster. Approximately 80% of its structure is made of carbon fiber composite, lighter than aluminum, stronger than steel. Its 4 low-noise General Electric F-118 engines each provide almost 19,000 pounds of thrust. They have special exhaust vents on the top of the wings, which, when its hot gases are mixed with cooler air, make it almost undetectable to heat-seeking SAMs. With a top speed of approximately 680 miles per hour and a service ceiling of 50,000 feet, this massive aircraft also can fly approximately 6,000 miles without refueling. No target anywhere in the world is safe from its weapons. The amount of weapons it can carry is awesome. 40,000 pounds of conventional, laser-guided, or nuclear bombs and missiles.
The airplane can carry a variety of weapons, almost anything in the Air Force inventory. Our primary weapons, though, are the guided munitions. Our bread and butter is the GPS-aided JDAM, the Joint Direct Attack Munition. We can carry that in several flavors. The 2,000 pound is the most common. We do have the 5,000 pound GPS-aided munition. We have a few of those left, and we're getting some more. And we can carry some standoff guided munitions, the Joint Standoff Weapon, the JSOW.
By the 1990s, the top-secret B-2 begins to enter service, but it would take on a completely different role than planned as an answer to Soviet aggression. The Soviet Union finally crumbles in December 1991, and with the collapse of the Iron Curtain, the new B-2 has an uncertain future. Originally, 132 B-2s were to have been built, but Congress wants cutbacks, and with a B-2 costing almost $2 billion each, something has to go. It is decided that only 21 B-2s would be built.
The B-2 is designed to penetrate the airspace of the Soviet Union undetected. Once the Soviet Union is no longer there, you don't need a big fleet of bombers designed to deliver nuclear weapons to a state that doesn't exist anymore.
As the B-2s begin to come off the production line, with them come a new breed of aviator. Based at Whiteman Air Force Base in Missouri, the B-2 squadrons become home and schoolhouse for all crews who fly the very latest in bomber technology. But the first hurdle many must cross is the initial impression of this secret aircraft.
Just the shape of the airframe, the glass cockpit, the displays, and the amazing contributions that some very smart engineers made to make that plane possible. And just looking at it fly was pretty amazing.
It's just an incredible marvel to see something of such an unorthodox shape. It's almost an eerie sense of awe that you get when you see that aircraft flying.
And I hear this kind of high-pitched whistling sound, and I stop, and I kind of drive closer to the flight line there, and out of like the shadows around the corner of those docks, I just see lights flashing. And I was like, what in the world is that? And it gets closer, and that was my first actual glimpse of a B-2. At the Air Force Academy, I'd seen flyovers, but nothing like that, and not that feeling like I have arrived. It was pretty cool.
And to be part of the B-2 program requires an elite caliber of pilot.
We look for aviators who have proven that they are among the best aviators we have in our Air Force. And then we spend a lot of time training them to understand the stresses of long-duration flight, to be able, as a two-person crew, to operate in that tactical environment and to respond to the kinds of taskings that we get.
Most of the pilots that fly the B-2 are unique in their own regard. You have to have somewhat of the thirsting desire to come fly an advanced weapons system like the B-2, but you also have to have the desire to fly extremely long missions anywhere on the planet. So that in itself, the mission provides or presents a unique challenge to most pilots, and some people just don't like that.
Every potential B-2 pilot who is selected is tested before he or she can get behind the controls of this highly secret aircraft. With over 130 computers on board, only the best of the best fit the bill.
The B-2 is a very intellectual airplane. It's a very brainy airplane. So you have to be really good at remembering what page in the computer everything is on. So if I want to change this, where do I go in the computer to change it?
B-2 training is longer than a lot of other aircraft. Now, most of us come from other airplanes. I came from a fighter. We've got guys here from cargo planes and tankers and trainers and other bombers. But really what the training is melding all of that experience into now how do you employ a low observable stealth aircraft that happens to, oh, by the way, cost $2 billion.
With the price in mind, a large part of the training involves the use of the simulator or sims. Each student spends months getting their bearings on this top-secret copy of a B-2 cockpit, learning every computer program, every knob, button, and switch before they are allowed to fly the most classified, sophisticated, and expensive aircraft in the world.
Obviously, this airplane is possible because of the computer technologies developed in the late 70s and early 80s. But the computers are only as good as the operators. As they say, garbage in, garbage out. So if you don't properly program the computers on the jet, or if you don't properly integrate with them while you're airborne, you may run into some trouble. But the human interface is really what makes it effective and deadly.
During the entire academic course, it's peppered with sims. They range from 2-hour sims to 4-hour sims. The 2-hour sims are really just so you can get used to pushing all the buttons there are to push. The 4-hour sims are more logically sequenced as a flight, where you take off, you go practice air refueling in the sim, and then you practice some bombing runs, and then come back and you do approaches. So they give you a good building block on the aircraft before you move into actually what your job is, so that you have a sound knowledge as a pilot about the plane first, and then you go and become a warrior. It's pretty cool.
Because the simulator is so intensive and realistic, and because the B-2 is a global warrior, the crews are trained to stay in one for as long as an actual mission might last.
Those first simulators are all 4-5-hour sims. You eventually do a 24-hour simulator, and you really get to know what it is like, what flying the B-2 is about. It is not about getting out there, yanking and banking, sweating, pulling G's. It's about capably managing the systems to most efficiently drop on the targets that you've been assigned, and then bring the jet home safely. You know, I'm not going to end up with the bill, but Uncle Sam is if something happens, and you want to be the best steward of this resource that you can. You look outside and get your...
But sometimes pushing that resource in a simulator can also mean pushing yourself to the limit.
We flew a simulator for 44.4 hours, and I believe at the time it was a U.S. record for a simulator flight. We actually stayed inside the compartment for the entire 44 hours and conducted our training as if we were really on a combat mission. It's a very important part of our combat capability at Whiteman, and so it was excellent training for that.
After spending months of practice in the simulator, the students will get their chance to actually fly a B-2. But for many of these pilots, it will also be the first time that they take the aircraft into harm's way and go to war. By the mid-1990s, the first U.S. Air Force B-2 stealth bomber pilots have completed training and are ready for the real thing. After months spent in the simulator, they head out for their first flight.
That's amazing. It was amazing. Sometimes you forget you're even in an airplane. You have to look out the wing and go, this is actually, there's still an airplane here, because there's no, there's nothing out in front of you as far as a nose. And it's just a wonderful, wonderful aircraft.
It's truly an awesome experience when you get the rumble of the engines as you're going down the runway, and you rotate that initial liftoff. It's almost like sailing on a carpet, just ultra smooth and just simply amazing and interesting.
And you take off, and you're sitting in a cockpit, but you look over in formation, you're like, man, that guy looks cool. And you're like, wait a second, I must look the same way. It was just awesome. It's a different aircraft. You know, the F-15, I equate that to a Corvette or a Porsche. You know, you're pulling G's. It's all about aggressive maneuvering, trying to get gun on or get missiles on to your adversary. And the B-2, I'll equate more to like a Cadillac or a Lexus. It's very smooth, but it has incredible systems, incredible capability.
Those that have graduated to the flight deck of a B-2 know that they have achieved something that very few people in the world can admit to.
I'm number 322 of the people that have ever flown in this plane, and that includes distinguished visitors and all those folks. So it's kind of a milestone, because we only train 4 people every 3 or 4 months. So it was quite an honor. It just seemed like a dream come true.
I think what makes the best B-2 pilot around here is a sense of teamwork, because I can't go out there and do the job by myself. A 36-hour combat mission, you cannot do it by yourself physically. It's nearly impossible. There's got to be a guy out there that I trust. You know, the guys here are really the cream of the crop.
As the 1990s draw to a close, the 21 B-2s have established themselves as one of the most cohesive and efficient bomber squadrons in the United States Air Force. They have honed their skills to pass all tests, but they have not been tested in battle.
If you are going to pay for it, it does you no good to keep it parked in a shed. And if you have an operational requirement to put ordnance on a target, why not use it?
But in March 1999, everything changes. As part of the NATO peacekeeping force, the B-2s attack highly classified strategic targets within the former Yugoslavia. Throughout the 1990s, NATO had been trying to keep the peace between the warring factions of Serbia and Bosnia. By late 1998, the conflict had escalated, and tens of thousands of Kosovan Muslim refugees faced annihilation. President Clinton issues an ultimatum to Serbian forces to withdraw or face the consequences.
President Milosevic has not yet complied with the international community's demands. Given his intransigence, the 16 members of NATO have just voted to give our military commanders the authority to carry out airstrikes against Serbia. This is only the second time in NATO's history that it has authorized the use of force.
The Serbs reject the ultimatum, and Operation Allied Force begins. To halt the fighting, targets are chosen that have either military or communication significance. Throughout Operation Allied Force, the B-2s conduct 45 sorties, often in weather that other Allied aircraft could not fly in, and produce incredible target hit rates. The B-2, if proof is ever needed, has come of age as the most awesome bomber in history.
B-2s from Whiteman flew less than 1% of the total missions, but dropped 11% of the bombs.
But its role as a peacekeeper is about to change with the start of the 21st century, when the B-2 bombers are among the first to lead the fight against terrorism. From 9/11 onwards, in Operation Enduring Freedom, the stealth bomber is hurled against the Taliban forces of Afghanistan.
When Enduring Freedom came along after the September 11th attacks, we were told we were probably going to go to strike targets, and we knew that the B-2 was going to be used in the first few nights, and those sorties turned out to be some of the longest combat sorties in history.
The secret flights to Afghanistan could be anything from 35 to 40 hours in duration, and because of the mission's length, the B-2s are refueled in the air up to 6 times, an extremely complex move that even highly trained pilots find demanding.
Refueling in the B-2, you know, in the F-15, you've got a glass canopy all over you. And so you see the tanker in front of you, and you see the boom coming down your left side, and you focus your mirrors so that you see where that boom is plugging into the jet. And you've got great peripheral vision. In the B-2, he plugs you about 20 feet back from the nose of your aircraft. So what I'm seeing, you know, as I drive up to the tanker, sure, I'm seeing the boom, but as it crosses basically past the canopy bow, all I'm seeing is the belly of the tanker and his wings. So you are now relying on the lights, you're relying on the boomer who's up there giving you those light signals, telling you forward, aft, down, up. It is at night or in the weather, I think it's one of the most difficult things we do.
F-16, you may take 7,000 or 8,000 pounds of gas, whereas in this airplane I've taken 110,000 pounds of gas all in one time, so obviously you're there a lot longer.
The sheer length of these missions puts a strain on the physical and mental endurance of these pilots. For many of the crews, a trip to the local store equals a solid power nap.
We ended up going down to the local Walmart store and purchasing Chase loungers, and we ended up laying those out, elevating ourselves 6 to 12 inches above the floor, and it also just caused the vibrations that you normally sleeping on the floor would feel to just kind of be mitigated, and allowed you to get what we called power naps. We kind of learned that if you can get yourself in a normal circadian rhythm cycle, sleep cycle of about 3 to 4 hours, you would find yourself well rested for the next 6 to 8 hours, and that really helped us overcome the fatigue factor of flying those long duration missions.
And the B-2's designers have taken care of the other essential needs of the pilots on 30-plus hour missions.
Luckily, they had the foresight when they were building the airplane to put in a porta potty, very similar to what you'd find on a camper. It sits behind the seats, and that gets well used on a 35-hour sortie.
But it is in 2003, during Operation Iraqi Freedom, that the B-2s would be put to their strongest test. Flying against Iraqi targets that are among the most heavily defended areas in the world, the B-2s will put stealth and their reputations on the line when they attack the heavy metal of Saddam Hussein's military might. In April 2003, Captain Jennifer Wilson of Miami, Florida, became the first woman to fly a B-2 stealth bomber in a combat mission. You're watching the B-2 stealth bomber on Modern Marvels. March 2003, the B-2 stealth bomber goes to war against Saddam Hussein's regime in Iraq. During Operation Iraqi Freedom, they will attack some of the most heavily defended targets in the world. Operating under extreme secrecy, they leave their home base in Missouri and set course for Iraq. But despite the intense secrecy, innocent patriotism almost gives the game away.
Well, we are basically over the eastern part of Illinois, and we hear Chicago Center, "Hey, United Flight so-and-so. If you look out your left window, there's 4 B-2s, and I think they're going to Iraq." And all of us are like, no! You love the patriotism, but the one thing we have is stealth. We got nothing else.
Once clear of any civilian air traffic control, the B-2s race towards their designated targets. It's game on, and the only control they now have are from their military commanders, ready at a second's notice to change their attack coordinates.
As we press toward the Iraqi border, we have on board our aircraft basically laptop computers. And these laptop computers get this satellite communication, and basically you hear, ding, you've got mail. You look on there and I see they wanted to change a target set. So now you have to go into your computer, hand jam the things you want to do, basically cancel that target. And then when I was about 2 minutes outside of Baghdad, I got another message. It said, well, we've got a new target for you. It's this airfield that we want you to strike. Now you're busy punching in, wearing out your finger, punching in the coordinates to the targets, figuring out if you need to take a radar shot of it.
But with all their high-tech weaponry systems, the final run to the target for these B-2 pilots is the same for any soldier going into battle.
You cross into Baghdad, and the eerie thing is, it looked, in all of Iraq, really, looks like flying over the Midwest USA. There's lights on, there's, streets coming out of it. But as you get into Baghdad, our doors open. And when the B-2's doors open, it's really the only time you kind of clinch up and say, oh, because now you're not a B-2, you're a B-52, you're any other aircraft out there. Your radar signature is exactly like any other airplane.
It is at this point Just before they drop the most sophisticated weapons on Earth, the crews are at their most vulnerable from enemy attacks.
That's the time you're hoping and praying that your stealth technology works. The time it takes for those weapons to fall, we're just basically kind of looking out the side, figuring out if there's any enemy stuff happening. Once the weapons hit, you know, we didn't see a lot of missiles shooting up prior to that, but once the weapons hit, looking over our left and right shoulders, missiles are going up like crazy, AAA missiles. They know somebody's out there because they just got bombed, and then you're just pressing to your next target. There's really no time to be afraid that one of them's coming after you. You watch them, and a couple times you're like, what's that one doing? Oh, it's not going for us. And then it was on the way out.
Having delivered their weapons, the B-2s make the long flight back to base. Now in their 20th hour of continuous flying, the pilots look forward to one sound that makes it all worthwhile, an American voice welcoming them back home.
I'll tell you the greatest sound I think my ears will ever hear. We were about 150 miles or 200 miles off the coast of New York. And across the radio, after all day hearing foreign controllers, we hear, "Stealth 3-1, is that you? This New York Center." And we're like, oh, you know, somebody who likes us, somebody who's friendly to us, you know, we're home. So we asked Center if we could be vectored over Manhattan, basically over the site of the World Trade Center, Statue of Liberty. And what an awesome sight. And I'll tell you right now, I've got goosebumps right now thinking about it. Looking down our wings at our stealth bombers in formation there over New York Center at the site of a tragedy from a couple years prior, knowing that you've been sent out by your nation to do something. You went out and did your best. You took care of the job you were at least asked to do. And now you're back on friendly soil.
In today's modern digital battlefield, all units can be controlled and directed from a central area or command post. From anywhere in the world, military planners can see an overview of a fast-changing scenario, and at a moment's notice, a target can be shifted, a new course set into the computers, and weapons headings and destinations changed at the click of a computer key. At the forefront of this technology is the B-2.
It's actually leading edge, and we now have the capability of doing secret or TS, essentially Microsoft email in the aircraft, as well as global worldwide communications with the voice SAT systems. It's unique.
Included within this digital battlefield scenario is the B-2's capability as a nuclear strike platform, a responsibility that the B-2 crews are more than aware of.
We don't fly around on our training missions with real nuclear weapons on board. We just don't do that for surety and safety reasons. But we train to that capability. And there's a big difference between operating with conventional weapons and nuclear weapons.
I'd say for all the B-2 pilots, that's the last thing you hope for, is a sortie to go drop nuclear weapons. Really, you want to be trained in it, but you want to be so well trained that the enemy knows you'll use them, and so you never have to use them.
The B-2 is the cutting edge of technological warfare. Its ability to use stealth and its enormous range to reach any target unchallenged is second to none.
In a network-enabled world, having a platform with that longer range, that is that hard to detect, and that can deliver a precision-guided munition onto a target can be a nice golf club to have in the golf bag.
The technology of the B-2 is so cutting edge that the United States Air Force has the B-2 on its books until 2040. It's a stamp of confidence that this 21st century warrior will be more than capable to deliver weapons of the future against enemies not yet known.
There are weapons that haven't even been envisioned yet that I'm sure we'll be able to carry on this airplane 20 years from now.
I think the things that you'll hear in 2040, if that's the date of the announcement of what it did when it lived, has yet to be written.
Every day I go out there and fly it, it's a challenge. And sometimes I just have to sit back and go, wow, I can't believe I'm flying a B-2. Because you're just busy and you're having a good time. It's a wonderful, wonderful job. I'd pay to do this.